first. You know that last week you were doing confidence intervals, right? And you did confidence intervals for means last week. And last week you guys had to determine whether or not, I'm sorry, I can't always hear that because my headphones, but you had to determine, let me shut that off. You had to determine whether or not, you know, you were going to use the standard, or whether you had the population standard deviation or not, right? And that was either T interval or Z interval. And I told you guys there was one more situation that you're going to deal with, and that's where you're doing a confidence interval for a proportion, and that's this week. So so we're only adding one more confidence interval topic. You have 3 total. You got the means, where you have to determine whether sigma is known or unknown, and then you have your proportions. And then the new thing about this week is, and I'm gonna these are the notes, I'll give these to you after. You guys have to determine the minimum sample size required to do whatever approximations you want to do. And these are the formulas for that. And there's only 3 of them. And there's not really a calculator trick in the sense for that. You know, obviously to find your Z critical value, you need the calculator trick or whatever you use. But these are just formulas you plug and chug. So I'll do examples of, I'll do one for proportions, and then I'll go into the minimum sample size required, since you asked that, Jessica, also, just to make sure I do the one that you asked. And then, so let's start with this. I took these from whatever assignment is this week, section 8 something, whatever section that is. This is one of those. So last week when I was doing this, I underlined specific portions of the problem so that I can determine, you know, what I'm doing with that, right? Let me use, I don't know, this color. And so you guys have your test this week. Okay, so you have a combination of different confidence intervals. So you're not going to be told what section it comes from. You're not going to be told, well, this is section whatever where it's means and sigma's known, or this is section whatever and it's means and sigma's unknown. You have to determine from the problem. So I'm reading this problem. I know I want a news group is interested in constructing a 90% confidence interval for what? So the first thing I want to determine is for what, in this case for proportion, right? And you know what, I'm going to write this down. Again, I wrote this, I wrote this last week. The 3 scenarios that you guys have. You guys have 1, proportions, which is what you're doing this week. And when you're doing a confidence interval for proportions, you're going to use, and I'll show you, 1 prop Z int. If you're using the TI-84, which is what I'm using, okay? So hopefully everybody has that. And then means, which was last week, where you had to determine either whether sigma was known. And remember, sigma is the population standard deviation. It's the symbol here. Sometimes they directly give it to you. Sometimes you have to read it and determine. And then sigma unknown, right? Those were the 2 scenarios last week. And if you're, you know, if sigma is known, then you go Z interval, and then sigma unknown, you go T interval, right?
So is this the one that we're doing for our project for week 11, where we put in all our stats into like that Desmo, and then we plug it in?
So you know what? That would be something to talk about too. The discussion for this week, because the discussion for this week corresponds to your project. So we have to go back to the project template again. So yes, you're gonna find you're gonna find a confidence interval for your sample from your whatever you did week 1, I guess it was, for your semester project, and you're going to find a confidence interval for a mean where sigma is unknown because you don't know the population standard deviation, right? So you use T interval, and I could talk about that after. You want to talk about why it's T, why you're using T scores for critical values, and then you want to interpret it the way that we interpret it in the homework. So you want to use that same interpretation. I mean, I'll tell you what I would expect from my students, and then what I would imagine other professors would expect from their students. So let me do this problem, and then I'll come back. I'll circle around to that, okay? And I have 3 sessions this week too, so we have time, all the same time. So, all right, so again, what confidence interval am I doing? A confidence interval for proportion. So that's the first thing I want to determine, which scenario I am going to use. I'm doing a confidence interval for a proportion. So now I'm looking here. I know I would use 1 prop z in if I'm going to do the calculator trick to find it. And I would use z-scores if I'm looking for the critical value. So that's the first thing that I want to think about. So a confidence interval for proportion of all Americans who are in favor of a new green initiative. All right, cool. Now, anytime we're doing a confidence interval, we're approximating something for a population. So now I need these sample values, right? What are the values from the sample? So out of 565 randomly selected Americans, my sample size is 565. 376 of them were in favor of the initiative. So what sounds different? So instead of last week, where it was like, hey guys, find a confidence interval for the population mean of blah. And then they gave you like, here's your data, you know, the mean of the sample is this, and the standard deviation of the sample was that, or the population standard deviation was this. Here they're saying out of this many randomly selected, this many of them were in favor of the initiative. In this case, this many of them were success. Remember when we did binomial, we talked about like 2 outcomes, success and failure. So you know that you're dealing with proportions. You have to now think about, remember what a proportion is. It's a fraction of a total. So, you know, I have 376 out of the 565 as my fraction of the total, as the amount out of the total that are quote unquote success, that are the proportion of Americans who are in favor of the new green initiative. That's my success. So we represent the number of successes out of trials as X, and X is 376 here. Now, sometimes they give you the number of successes, sometimes they give you what we call P hat. Remember I told you guys it's really important to know your variable, you know, your variables. This is P hat, which is a sample proportion. So a proportion is a fraction, is a decimal. Like if I use my statistics students as a sample of the population of statistics students, let's call it all of USA as my population of statistics students, then I talk about like the proportion of my students who have brown hair, for example. Let's say I have 20 students in my class and 15 of them brown hair. So the proportion from my sample would be 15 out of 20, right? That would be my P hat. That's the proportion from the sample. That would be my P hat. That's what P hat is, the proportion or the sample proportion. Whereas P, you're going to see P, and I'm going to show you all 3 representations again of the confidence interval. P is your population proportion. If my population is all statistics students, you know, in the United States, and the number of them that have brown hair, then that, you know, proportion, that fraction would represent, you know, large, this P without the hat over it. So know what the notation is, right? So P hat here, if I wanted to find it, is X over N. 376 out of the 565. Now I could potentially, and let me do that on my calculator. I could find that now, 376 out of 565. I'm going to show you how you don't have to find it now, but this is how you would find your sample proportion if you need it. Yeah. So 0.6655 if I'm rounding, right? Cool. So notice the difference between last week and this week. We're still doing a confidence interval, but now it's for a proportion. So now my notation is changing. I'm doing a confidence interval for P, not mu, right? Last week I wrote that a lot. I'm not doing that this week. I'm doing a confidence interval for P. So you're going to see P for population proportion. If you're doing a confidence interval for means, that would be mu. And then I'm looking for different values now. It's a proportion. So I'm looking for success out of sample size. How many successes out of, you know, my sample size? Or sometimes they give you the percentage out of. So in this case, P hat. I'll see if I have an example of that. Again, I have 3 sessions this week. We could look at different cases. But so with 90% confidence, the proportion of all Americans who favor the new green initiative is between blank and blank. So this is the interpretation of this confidence interval. If you remember last week, I did interpretations. We were like, we are this percent confident that the blah, 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 blah is between whatever and whatever. Basically, this portion comes straight from the problem. What do you want to find? a confidence interval for the proportion of all Americans who are in favor of new green initiative. So I'm 90% confident that the proportion of all Americans who favor the new green initiative is between, I'm basically copying and pasting if I have to rewrite it myself. And that I would like to see, if you're in my class, on the semester projects, you know, that kind of interpretation. I'm sure other professors do too, you know, because the project is basically given to you in terms of template and stuff. So we want to know that you can interpret the stuff that you're finding. So with the discussion this week and, you know, corresponding to your semester project, you want to interpret the confidence interval that you get. You are what % confident that the true value of whatever your situation is between whatever and whatever. All right, so talking a lot, right? But now that I know I'm finding a confidence interval for P, I'm going to go to my calculator and I want to do, you know, 1 prop Z int, right? Confidence interval for proportion, 1 prop Z int. So stat, and then I'm going to go over to test, right? That's where all my interval stuff is. So down, past all this, you're going to see this again, by the way. All the stuff that ends in test, that's coming soon, don't worry. But you want an interval, so scroll down to the stuff that ends in interval, and you're looking for 1 prop Z int. And it tells you, right? Prop, think proportion, Z scores when you're dealing with proportions, and it's only 1 sample, so 1 prop Z int, it ends in interval. I want an interval. Notice this time it's, you know, a little bit different in terms of what it's asking for than what we were asked for last week. My X value is 376. It asks me for that directly. My N is my sample size, 565. I want 90% confident, so 0.9. Remember the C level is confidence level, always in decimal form. Boom. It gives me my interval and interval notation. I'm going to write that over here. So 0.6328 to 0.6981 in interval notation. So that's my answer. 90% confident the proportion of all Americans who favor the new green initiative is between 0.63, round to 4 decimals, to 8 and 0.6981, right? That's my answer for this particular question. But I go beyond what the question asks because you could be asked different ways for the same thing. I want you to notice it also gives me P hat. So even though I could find it prior, it gives it to me too. So I could, if I want to, either check that or just wait and find it here. And then just obviously I could check to make sure I have the right sample size there. If they want it in what we call tri-inequality form, that's this form. The lower end is, you know, 0.6328. The upper end is 0.6981. And this is tri-inequality. Tri meaning three things. The middle is P because it's a confidence interval for a population proportion, and then you have the low end and the high end of that. So everything in between, open interval, right? Not inclusive. Everything in between those values are possibilities of the proportion of all Americans who favor this new green initiative. And I would say the majority. That's more than 50%. You know, what does it mean? You know, for the population. So a lot of people like a green initiative, which is good because technically, I mean, you know, whatever it is, hopefully it's saving the planet in some way.
I have a question.
Yeah.
So if they had something like 73%, so will I change that into a decimal?
Wait. If you mean the confidence level for
so like if the X was, so say X was 73%.
I like
so,
that you asked that.
So would that be like, would I have to change that to a decimal form?
Here's the thing. I like that you asked me that, and I was gonna get into that.
Sorry.
I don't even know if you guys have the question, but remember I said that they could potentially give you the actual sample, number of successes from your sample, or they can give you the percentage of success from the sample. So instead of saying, let's say, of the 565 randomly selected Americans surveyed, 66.55% of them were in favor of the initiative. So sometimes they give you P hat. This one doesn't do that. Sometimes they give you P hat instead of X. And in that kind of situation, if I'm using this to find my interval, it asks me for X. I never put a decimal here. It's not going to take a decimal, because X represents like a discrete value. It has to be a whole number. I can't have a decimal amount of people or whatever. So if I were to calculate, let's just, I don't know, make something up. Let me say, I'm gonna make something up here because I want something that's gonna give me a decimal. Let's just say that they said instead of 376 were in favor, they said like 33% were in favor. Hopefully that gives me a decimal. That's my p hat. You have to calculate your X if they gave you p hat. And so you would do, 0.33 times, and if I have time later in the week, I'll come back to this again. But you see how if I were to calculate X, if it were a decimal, check this out. It's gonna tell me error. It's not gonna make sense because X can't be a decimal. So if I were in that situation where they gave me the percentage and I had to calculate the X, if it were a decimal, I have to round it to the closest whole number. Otherwise, it's not gonna work. You never have a decimal here, and you're never putting a percentage here because X represents the number of successes. How many, out of the total sample do I want? In this case, 376 out of the total sample. This is called the number of successes that are in favor of whatever I want. In this case, the green initiative. Okay, never a decimal here. So if you had to calculate X, which maybe there's an example of that, maybe later in the week. If I had to calculate an X and it was a decimal, I have to round to the closest whole number because it's not going to work on the TI-84 unless X were a whole number. Has to be a whole number. Does that make sense?
So if it was 33% and we made that a whole number, so that would be 33, would that like round to 1? Like you have to round down to?
Well, this is if they gave me p hat to be 33%, and I'll see if I can find, or okay, if I can find one in your assignment, I'll pull one from somewhere else, or I'll make one up myself because okay, that's a different situation. In this case, okay, give me X. Let's just say they're giving me X. If I have to come up with X, that's another thing. I'll come back to that. I'll circle around to that. But that's a good question because sometimes they do give you the percentage. Instead of saying this many were in favor, they could say this percentage were in favor. And that's not my X. X is a whole number. Okay. Okay. So for now, they're giving me X, right? And then we'll come back around if they don't give me X to another case. So again, confidence interval proportion. One prop z int because I'm looking for a proportion. They're going to ask me for X. In this case, I'll write it again, 376. And my N, my C level is 0.9, right? And it'll calculate p hat for me and everything else. P hat sample proportion. 3 ways to represent the confidence interval. Interval notation, try an equality form, and then there's one in terms of the point estimate. Remember I did this last week. The point estimate and the margin of error. So I find my margin of error without going through the formula. I use the confidence interval that I found on my TI-84 to find my margin of error. I'm not asked for the margin of error for this particular question, but I'm going to go into that as well just for practice, okay? It's not asking me for that. Technically, I'm done for this particular question from the assignment. But let's assume I was asked for the margin of error. Same thing as last week. You take the max minus the min and you divide by 2 to find your margin of error. I like to find my margin of error from my confidence interval because it's faster. So I take these values that I just found from the calculator, cut them in half, subtract them, cut them in half. So my margin of error is going to be 0.6981 minus 0.6328, and then divided by 2. My margin of error in this case is 0.0327 if I'm rounding to 4. Now again, this is extra. This is not necessarily what the question asks me for. This is just if they were to ask me for a margin of error. Okay, because remember I told you guys last week, you want to go beyond what the question asks you to practice the process, because you could be asked for all or a piece of any of these things. This one asks you directly for the confidence interval based on the interpretation, but it could ask for it in terms of, my interval notation. It could ask for me in terms of the try and equality form. I've seen both of these already in the assignment from this week. And then this is the other representation in terms of what we call the point estimate and the margin of error. And the point estimate in this case is the sample proportion, which was, what is it, 0.66. So this would be 0.6655 plus or minus the margin of error, 0.0327. So these are the three ways that we could potentially represent the confidence interval, three ways that you could be asked to represent the confidence interval. Again, I'm going beyond what this question asks. I think, I don't know what question this was. Question 3, question 6 on chapter 8 to 83, the first assignment, okay? I'm going beyond what it asks to practice some of the things that we might need. And again, I'm not using the, what do you call it? The formula. I'm using my TI-84. Why is it doing that? I'm using my TI-84 trick to make it a little bit faster. This is part B of this question. My thing is like delayed and it's, you can do it. Yay. Okay. Yo, I didn't press it that many times. Okay. Did you guys hear? You heard my thing. I didn't do all that.
You have a ghost in your house.
It's tripping. Yep. I might. Oh, Jesus. All right. Well, as this comes back. Oh, shit. As this comes back, remember this type of interpretation of the confidence interval as well. Come on, guys. Green initiative. You remember this from last week. If many groups of 565 randomly selected Americans were surveyed, right? They took that from the sample size. If we continue to do this sample, then a different confidence interval would be produced from each group because it would have a different sample proportion. About blank %. So this is like an input for your problem. I don't know why it's doing that. About blank % of these confidence intervals will contain the true population proportion of Americans who favor the green initiative. And now this is doing this. Do you guys remember last week how we did that? And then about blank % will not contain. Yeah. So about 90% will contain because it's a 90% confidence interval. I don't have to put the percentage because it's here. 90% of these intervals will contain, because it's a 90% confidence interval, who favor the green initiative, and blank % will not. What % will not? What's left? 10%, right? I'm just going to put that. I'll add that later to the notes. So again, similar interpretation as last week, right? I told you there's a repetition involved in confidence intervals. What's the difference? Some of the notation, and then obviously the calculator trick. Now I didn't do the critical value yet because I don't need it if I'm using the calculator trick, but I should know how to find it, which it's not necessarily different from last week. I should know how to find it, you know, because I'm going to have to use critical values later. And then actually I'm going to need critical values for this when I do sample size determination for this week. You have to use critical values. So I could do that when I do that problem. So here, let me pause my recording for this real quick, and then okay.